Okay, so hello everyone and warm welcome to all of you. This is the series Science with Very Important Persons, hosted at Taiwan University. My name is Minan, and today we are going to discuss with our very special guests the impacts of artificial intelligence on social interactions. AI has been around for many years and has been influencing different areas of our lives. It continues to affect the global economy, healthcare, and education. By 2030, around 70% of companies would adopt at least one type of AI technology, and the global economy may increase by up to 14%, the equivalent of around 16 trillion US dollars.
Wow.
In education, AI tools can help make global classrooms available to everyone, including those who live in remote areas, who speak different languages, or who might have visual or hearing impairments. In healthcare, AI will improve patient outcomes by 40% and with a reduction of 50% in the treatment cost. On the other hand, more than 50% of jobs in the European Union could be replaced by AI within 20 years. Our concern is, can artificial intelligence replace humans? In a moment, we will discuss these exciting issues with our speaker. And now I would like to share some information about our very, very special speaker. Dr. Vinton Cerf is the Vice President and Chief Internet Evangelist for Google and the former President of the Association for Computing Machinery. Together with Dr. Robert Kahn, Dr. Cerf led the design and implementation of the Transmission Control Protocol and the Internet Protocol that are the basis for the current Internet. The Internet has enabled global collaboration on all aspects of our society, industry, economic development, media, and communication, and governance. Without the Internet and the World Wide Web, the world would not be as it is today. Dr. Cerf was appointed by President Obama to serve a term on the National Science Board in 2013. He's a fellow of many institutions, including the U.S. National Academy of Engineering, the U.S. National Academy of Science, the British Royal Society, and the Swedish Royal Academy of Engineering. Dr. Cerf has been inducted into the National Inventors Hall of Fame and has many awards recognizing his leadership and contribution to the Internet. It is my deep honor to host this talk with Dr. Vinton Cerf. Please welcome Dr. Vinton Cerf, one of the fathers of the Internet. Hi, Vint. Your words.
Well, good evening to you, and good morning where I am in Washington, D.C. Thank you so much for inviting me to join you today. One small observation to make: the World Wide Web was invented by Tim Berners-Lee around 1991. Bob Kahn and I started our work on the Internet in 1973, so there's a gap there. We turned it on, however, in 1983, and so 8 years later, Tim came up with World Wide Web, which is a layer of protocol above the TCP/IP layer. And this just lets me remind all of the students that the architecture of the Internet was designed to be expandable. It has multiple layers, and in any particular layer, you could have more than one protocol. So if you decided you weren't happy with the way the Internet was working, you could design a new layer, or you could design a new extension in a particular layer. So a specific example of this extension within a layer is that in the early 1980s, optical fiber became available. Up until that time, Internet was carried by radio and by dedicated telephone circuits or coaxial cable or Ethernet connections. But optical fiber came along, and we just stuck that in the physical layer of the Internet, and it carried bits just like everything else, but at much higher speeds. So today, what we are doing right now with this video conference is going through a network that's carrying the traffic at approximately 400 gigabits per second. And the original ARPANET backbone, the network that led to the internet, was running at 50 kilobits a second. So it just gives you a sense for what happens over a 50-year period of time.
That's awesome. That's awesome. Vin, I know that people know you as the founding fathers only, of the internet, but I would really want to get people to know you a little bit more as a very, very simple person. So I would like to ask you some ice-breaking questions, if you don't mind. So the first one is, what superpower have you ever dreamed of having?
I think I'd like to fly. I've always dreamed of that, and of course, you can tell from the fact that I'm wearing this Star Trek pin that I always want to look towards the future so we could go faster than the speed of light. Now that would be something. Unfortunately, Dr. Einstein says you can't do
that. The second question is, who had you wanted to be if not the father of the internet?
Well, I'm not the only father of the internet, so let's make sure that everybody's clear. Bob Kahn and I did the original design, but there excuse me. It's a good thing. It's a good thing that we can't transmit viruses through the internet. The only viruses we can transmit, unfortunately, are programs that are harmful. So, unfortunately, even the internet.
So maybe that's the future of the internet or the future of AI.
Well, to keep those things from propagating in the net, I certainly hope so. Anyway, to come back to the point about internet, it was assembled by an enormous number of people, and we should acknowledge all of that.
Right.
And now I have to go back to the question that you were asking, which I've now forgotten. It was, ask the question again because it just went out of my head.
Who had you wanted to be if not the father of the internet?
Well, I haven't really thought about wanting to be somebody else. I was happy being me. On the other hand, and now that you've asked the question, maybe Galileo. Although he had a really tough time, as you will remember.
All right. And why him?
Because he was on a voyage of discovery. I mean, imagine what it must have been like when he saw the moons of Jupiter and realized that, this this geocentric model that the universe circulated around Earth was wrong, and that the heliocentric model was replicated in the planets with their moons going around them. And that must have been really astonishing. There's another person who had a similar discovery, which must have been very mysterious for most people to hear. That was a guy named Leeuwenhoek, who was a Dutch lens maker, and he invented the microscope. And he took samples of his, of some of his saliva and put it on the slide, and discovered that there were things moving around, little live creatures in your mouth. And I'm sure that if he tried to convince people that what he was seeing was real, I'm sure they'd say, well, obviously you're hallucinating. I'm not feeling anything moving around in there, so this can't possibly be right. And yet, of course, he was. So those are people who have been on voyages of discovery to push the boundaries of our knowledge further out. And I find that really quite fascinating.
Great. Awesome. We are very happy that you stay yourself because we love the invention of the internet. And that's why we are very thankful for you and Bob, who co-invented the internet with you. Anyway, AI has been around for many years, and recently we have seen the rise of ChatGPT, which is a language model trained by OpenAI. Then could you tell us what you believe are the most positive impacts of AI and ChatGPT on education, healthcare, and the economy?
Well, at the moment, it's creating something of a disruption because it's not entirely under control. It hasn't got the right kind of guardrails. I think everyone should understand that artificial intelligence research started way back in the 1960s. And an organization called the Advanced Research Projects Agency was funding research in this area around a dozen different universities. And that, by the way, is why the ARPANET, the Advanced Research Projects Agency network, was built to connect the computers of all of those universities together so they could share their results. But those were very early days, and the results were, I would say, modest relative to what we now know we can do with very different methods. So we could get them to play games like checkers, and eventually we got them to play harder games like chess. But the most significant introductions came, first of all, with what were called expert systems. These were assertions of the form if, then, else. So if this condition applies, then this conclusion could be reached, or this action should be taken. And they would take information from experts, human experts, and they would try to codify what they knew in the form of these if, then, else rules. So that was called rules-based expert systems. And that worked well for certain applications, but it got very unwieldy because you had a large number of rules in order to deal with so many different special cases. And eventually some of the rules actually conflicted with each other. And it was hard to figure that out. And so progress was, I would say, limited at that point. Now we're talking in the 1980s. But in the early 2000s to mid 2000s, there was a beginning exploration of what are called neural networks. These had actually been explored in the 1960s, but the only neural network that was being looked at was called a perceptron, and it was one layer deep. And what happened during the 2000s and 2010s is that we discovered how to build neural networks that had hundreds of layers. The reason that's important is that these neural networks can ingest a huge amount of information. It could be digital information, it could be text, it could be imagery. They ingest a huge amount of information, and they are trained to recognize what it is that they have ingested. And because there are so many layers deep, they can hold a huge amount of state information in order to characterize what they have captured. So in the case of the ChatGPT and Bard at Google and others, literally billions of lines of text have been ingested into these systems. And the patterns that the text make are captured by the weights that go along with all the neurons in these multi-layer neural networks. The result of that is that the systems learn, for example, how to associate a string of text with other strings of text that it's seen before. In the specific detail is that it's not word by word. They actually take text in phrases and turn those into tokens. And so the hierarchical and probabilistic structure they build is relations among tokens. So when you prompt ChatGPT or Bard or the others, it takes the text that you provided to it, it tokenizes that, then it introduces those tokens into the neural network, and it draws likely words that it should generate based on the input. And so it keeps calculating what's the next most probable token to put in the growing string of output. Now, so that's basically how it works. It has ingested a lot of text. It knows how words go together just based on the examples that it got. These things sound very normal, like normal human discourse, because it's ingested normal human discourse. It's ingested text generated by people. And of course, it doesn't necessarily have any idea about facts. It just knows that certain words go next to other certain words with some probability X. So when it generates its output, it doesn't know whether it's saying anything true or false, but it does generate grammatically good sounding text, which means it can appear to be quite confident when it's telling you a falsehood, because it's generating good quality text. It's just not generating good quality information. So the good thing about these devices is that they can be quite creative. They can tell stories. I asked it once to write a story about Vint Cerf discovering a Martian in his wine cellar. and it generated a story about the Martian. It didn't say how the Martian got into the wine cellar, but it got into the story about how I discovered it, how it was staying alive by drinking my wine. And it went on for about 700 words or so. It was actually fairly creative. However, it also gets facts wrong because it doesn't know what's true and what isn't. So I asked it to do another task. I said, write an obituary for Vint Cerf. And it attributed to me things I had not done, and it attributed to other people things I did do, and it didn't know the difference. So we have, this is very useful if you just want fiction to be written, if you want creative writing or something like that. But it is not a good source of information because it doesn't know what's true and what is not. Right. So these systems are still need to be somehow disciplined, and even if you fed them nothing but factual information, you will get confused about what's true and what's false because it doesn't keep the entire sentences. It has tokenized everything. Right. And so it can juxtapose a true fact and a false one without any difficulty at all. Yeah, I want to turn to the value that we get out of these things. So let's set aside the chatbots for a moment and look at other forms of neural networks. They have done a spectacular job of translation from one language to another. They ingest huge amounts of text. They know what text goes with what other text. They're very good at doing text translation. They can do speech recognition, and so we can get captions, for example, in real time, which are pretty good. They aren't always right, but they are pretty good. We can also do real-time text-to-speech generation, and so you can have a conversation with a computer in order to get tasks done or to get questions answered. And so Google, for example, has a service called Google Assistant, which plays music and answers your questions and takes lists of shopping lists for you, as do some of the other companies in the same business. So we've been able to apply neural networks to some very important functions. You alluded to medical diagnosis, for example. We can train these things to look at images of cells and determine whether the cells are cancerous or not. And in some cases, they can detect medical conditions better than the doctors can because they've been trained by inputs from many, many doctors. So in some ways, we get the sum of all of those doctors' knowledge. So it's an incredibly powerful technology, and you were right in your predictions that it will become part of many tools that we use. At Google, we intend to AI enable a lot of our applications. But we have to be very conscious of the fact that it doesn't always produce correct results. Sometimes it will fail. And if the application has high risk associated with it, for example, self-driving cars, you want to be very careful about how much you apply these technologies in high-risk conditions. If it's a low-risk thing like entertainment, then one is much less worried about it. But the closer you get to something that really counts, like a decision about making a financial investment or obtaining a loan or getting admitted to a university or getting a job, at that point, I think you want human intervention to make sure that the neural network has not made a bad decision.
Right. Vin, it's very good that you mentioned the caution when dealing with AI and ChatGPT. I admit that recently I have given the ChatGPT some tasks, and it does very well, by the way. And I could not believe that one day in a lifetime, there could be a kind of robot that can do some jobs of my assistant. So talking about the caution and the very fast advancement of AI and ChatGPT, there's a concern, and actually there is a question that came from two high school teachers in Vietnam, Nguyen Van Dinh and La Thi Hang. They ask, there's a concern that AI may become uncontrollable someday. Do you believe that this is a possibility, and how ready are we for that day?
Well, first of all, it only becomes uncontrollable if we decide that we want to give it ability to act without any intervention. I'll give you a few examples. Today we are reliant on software to do things autonomously, and I'm not even talking about self-driving cars. Think about elevators where you go into the elevator lobby and there's a little display and it says, what floor do you want to go to? Right. And you select the floor and it says, go to elevator number HR3. So you go to elevator HR3 and you get in and there are no controls in the elevator at all. There's a little display that said you're going to floor number 16, maybe someone else is going to floor number 12. There's a piece of software that's deciding which elevator you should go to and where the elevator is going to go. And you have no ability to control that. So you're dependent on that piece of software. We're also dependent on the software that makes this video conferencing work. Right. And again, it needs to work correctly, or the images will break, or the circuit will change, and we won't have the connectivity anymore. The whole damn internet is full of software that makes it go all over everywhere. So we are dependent on software all the time. It's just that we need to make sure that we have tested the software adequately, and we build guardrails around its behavior so we can detect when it's malfunctioning. And the problem with some of the artificial intelligence and machine learning systems is that sometimes it's hard to tell that it is not functioning correctly. So here's an interesting exercise that a high school teacher might choose to do: have the students interact with a chatbot, maybe have it write a story, or maybe have it ask some questions about some interesting process or an object or what have you. And the chatbot produces some output. Now, the homework assignment is to go figure out whether what the chatbot said was correct or not. And that requires research. That might require, going off and doing Google searches on the internet, but it might also require going to a place called a library where they have things in them called books, and they have information in them, and your job is to figure out which books you should be looking up in order to figure out whether the chatbot produced verifiable information or not.
Wow. So this depends on our will, right? And on a decision, if we want it to be controllable or if we want it to be uncontrollable.
We don't want it to be uncontrollable. We want it to be, have guardrails and boundaries and things. So to give you an example, and if you were to look at an airplane, airplanes have what are called autopilots in them. They sense sensor information from the aircraft's speed and height, altitude, its attitude, and so on. And then they try to keep it flying on an even keel and on course. That's all automated, but we have pilots there in case the automation doesn't work. And that's what we need to have, I think, in all of these applications. You need to build and design the system so that it can detect when something is going wrong. So when the plane goes off course, the automated pilot should notice that and correct the course corrections. But if it doesn't notice that, that's why you want a pilot.
Right.
Now, I'm sorry to interrupt, but there is a joke which is told about airplanes in 2025, just a couple of years from now. And in the cockpit, there will only be two people, a pilot and a dog.
Okay.
And the pilot is there to feed the dog, and the dog is there to keep the pilot from touching anything.
Okay. That can be a future. We have a high school student named Bao watching live in the conference room, and he would like to ask you a question. Can I have Bao speaking from the conference room, please?
Hello?
Hello, I can hear you.
Okay, great. So actually, before I start, can I say a couple of things?
Yes.
Go ahead.
Okay. First, it is a great honor for me to be able to meet you today, even so if it's just through a video call. I like when I was a bit younger, and when I first heard of the TCP/IP protocol, it was incomprehensible for me, basically, because how can something made in the 90s hold up so well up until today? Like, how is it still the standard? And I mean, after hearing you explained, I think I understand it a bit more, and I really admire you for what you've done for technology and your creation of the internet as a whole. And
Can I interrupt you for first? Thank you very much. That's very kind. I just want to remind you it was designed in the 1970s, literally 50 years ago. The internet was first designed and it was turned on operationally in 1983, 40 years ago. And the reason that it keeps working is that the design is very simple. We try to keep everything very, very simple. And sometimes simplicity is your friend when you want something to last a long time. Anyway, let's go on to your question.
Thank you. So I asked the father of the internet. I don't think AI itself will be where it is today without the creation of the internet and the sheer amount of data that is fed to it. So the question I wanted to ask you was, in a world where AI workers will eventually replace lower level workers, what do you think is the direction the economy will head in?
That's an extremely good question. And historically, you probably know that the invention of new technology almost invariably, sometimes the technology replaces work that was done by people. Automation is a term that was used in the 1960s and 70s to refer to that, but it also created new jobs. However, you had to be trained to do the new jobs. It might be that you became a designer instead of someone who actually operated a lathe to create a bot, because the actual processing was done by an automatic algorithm. But somebody had to do the design to make whatever it was that produced was useful. So I anticipate that what will happen is that the AI applications and machine learning applications may allow robots or other automated tools to perform work that people used to do, but the people will still be needed to repair the machines, to design and build and program the machines, to come up with new designs that the machines can make. And so I'm not too worried about people not having jobs. I am more worried, however, about people having enough knowledge in order to do the new jobs that are created. And that's why I'm so glad to see all of the students in school, because learning is how you manage to prepare yourself for the future.
That's wonderful. Thank you.
Thank you, Bao. Thank you for the question. Very good question. And thank you for the answer. Vin, 2 days ago when preparing the agenda and the flow for today with you, I asked the ChatGPT to pretend to be you. And give to give me possible answers to my questions. The thought I had back then is, can one day ChatGPT replace you in answering me? And in general term, can one day AI replace human interactions? If it can give me your possible answers, can it replace you?
Well, I don't think so. In certain contexts, it could. First of all, it's going to have knowledge that's limited to up to the point where whatever it was that it had learned, it could learn. So we had an example of this with the ChatGPT, which had been fabricated up till 2021. And it was having an interaction in 2023 with a reporter, and the chatbot didn't know that there was a 2022 or 2023 because it hadn't ingested any information about that year, and so it had a big argument with the reporter about what year it was. So the chatbots are limited in their learning capacity unless they continue to learn, and it turns out to be really expensive to train these things to do this sort of text interaction. So it's not yet clear for what kinds of tasks these neural networks are best suited. Usually it's going to be a task that doesn't have too many surprises in it, that has sort of well-defined set of rules that it's supposed to follow. You may use image recognition, for example, to identify parts. You might learn how to put parts together. You might be able to even detect that you hadn't put them together correctly. But I'm not terribly concerned at this point that no one will have any work to do. I think it's just that we should be ready to do new work. And that actually is a good thing, because I notice that most people enjoy their work if they're learning something new. If the same job, if the job is repetitive and you do the same thing over and over again, for some people that's okay. For some people, I know how to do this and I know how to do it well, and I'm happy doing that. But I think most people find jobs interesting if they're learning new things.
Then is it true that the bigger data it has, the more intelligent the AI can be?
No, I think that's not a good equation. The amount of data is less important, I think, than the kind of data that it has. It's certainly true that you get, for these chatbots, you get a more realistic interaction, the more data that it has, because it has refined how to generate the text.
Right.
But it's just a text generator. It's just trying to figure out what's the next best word or next best phrase to put in the sentence that we're building. But that's all it's doing. One thing that we've noticed, for example, is that it doesn't know how to reason. It doesn't build a model of the interaction. If you ask it to solve a problem, a mathematics problem, if it happens to have encountered some text which has the answer in it, it might actually generate the correct answer. But it is certainly nothing like the programs like Mathematica and some of the others that actually know how to do the math, can take an equation and can manipulate the equation. That's not neural networks at work. That's actually more expert systems at work, knowing how to do symbolic manipulation according to a set of rules.
Yeah.
So I don't think intelligence is exactly the right word here. Now, I have to admit, when AlphaGo won the 4 out of 5 games against Lee Sedol several years ago playing Go, a lot of people came away saying, wow, that's amazing. How did it do that?
Right.
And the answer, I think, is that these systems are very good at pattern recognition.
Right.
They've also had the experience of playing millions of games, which means they have seen millions of games worth of patterns, and they've seen which patterns have produced successful outcomes and which ones don't. And so it's, for narrow kinds of applications, it's actually quite astonishing what this Bayesian pattern recognition is capable of doing. So we should be very careful to understand the kind of intelligence that it is exhibiting. It's not clear that it can take a visual scene, for example, and understand what's going on in that scene, and then figure out how to solve the problem associated with it. So, example, suppose you have a glass tube with a hole in it, and in the middle of the tube is a little peanut. And the only way to get the peanut out is to get a twig and push the peanut out through the hole. It's not clear that a chatbot would figure out how to do that, but birds know how to do that.
Yeah.
They have to go get a tool to push the little net out of the hole, and they use doing it. So we're a long ways from the kind of symbolic, analytic, and model forming intelligence that humans are capable of. That doesn't mean we won't get closer and closer to machine learning systems that can formulate these kinds of things. But my view is that we're some distance away from that.
Thank you very much. You mentioned two things that I found profound and meaningful to me, and at the same time scary, because the ChatGPT that I have been using can be very good at pattern recognition. And you mentioned that it's more realistic than ever before. And my question is, will they ever get enough data to replicate human emotional intelligence, empathy, improvisation, creativity, to really fully replace humans? Can that day ever come?
Well, here's the problem that we have, and you're anthropomorphizing, which, to use a big expensive word, more than you should here. What these systems are doing is a very good simulation of human discourse.
Yes.
And remember that it is incapable of generating anything that it hasn't already ingested and has incorporated into its vocabulary. So even though it has read, I'll use that word kind of lightly here, it has ingested huge amounts of text which describe all kinds of situations in which human emotions are articulated. What you're seeing is the simulation of discourse. You're not seeing something that has emotion. You're simply seeing something simulating the discourse based on all of the sentences that it has incorporated and ingested. And you should not confuse those two things. The fact that it's generating text that is appropriate to the conversation and the context does not mean that it is feeling anything. It just means that it has found in the text that it has ingested the things that people commonly say in those conditions, in those conversations. But please don't misunderstand the simulation of discourse to be the same as a thinking, living entity that has emotions and feelings, because it doesn't.
Right. Thank you very much for that. You eased my concern. Talking about something human and something that makes us, teammates and stuff. Apart from the technical part, what did you learn from the internet invention process?
Well, one thing I learned right away is that patience and persistence are your friend. Some of these projects have taken a very long time. In an earlier remark, I reminded all of you that the internet design was started in 1973, which is literally 50 years ago. And it's taken that long to get to where we are today. We're quite far along, I would say, but still 50 years is 50 years. Some of my other projects have taken, similar kinds of long periods. I'm working on an interplanetary internet for space exploration, which is why I love wearing this little pin. Actually, it's a big pin. However, that's taken 25 years to get to the point where we are ready to deploy this interplanetary backbone system in support of the Artemis mission that's coming up very soon. It's already launched. So patience and persistence is one thing. The second thing is that if you're going to do anything big, the big lesson you learn right away is get help, particularly from people who are smarter than you are. So Bob Kahn and I were very fortunate that we were able to find people who were excited about the project and wanted to be part of it and were willing to contribute to it, which raises one other very important point, and that is that it's hard to do something big if you can't sell other people on the idea that they want to do this too. There's a book which the students in this class may never have read this book. It's about a character named Tom Sawyer. It was written by Mark Twain in the 19th century. There's a scene in the story where the Tom Sawyer character is whitewashing a fence, and manages to convince his friends that whitewashing a fence is fun. It's not work, it's fun. And he'll reward them with an apple or an apple core or something when they finish doing the whitewashing. So selling people on your ideas is really important if you want to get something big done.
Could you tell us the very interesting story about the collaboration between you and Bob Kahn and others in your metaphor of a stone soup?
Oh yeah, this is a lovely story. The story goes something like this: a wanderer shows up in the village, and he says he takes a stone out of his knapsack, and he says, "I would like to show you how to make stone soup." And of course, the villagers are all amazed at how to make soup out of the stone. So they get a big pot and they put a stone in. The wanderer puts a stone in the pot. And they put water in, and he samples it. He says, this would probably go better if we had maybe some carrots or something to go in. So something. Oh, I have some of those. And they put the carrots in. He tastes it again. And he says, if it's getting better if we put some onions in, or maybe some lettuce and celery. And so slowly and bit by bit, people are adding things to the pot. And in the end, of course, they make this fantastic soup, and everybody runs around saying, "Wow, stone soup is great." Well, that the clever person managed to get everyone to contribute something to make the stone soup happen. And in a way, that's how the internet has evolved. It has, I mentioned earlier about the layered architecture. It was designed to be extensible. It was designed to allow new ideas to be incorporated into its architecture. And people with ideas have come and taken advantage of that. And so it's possible to think of the internet as it continues to evolve as an elaborate stone soup story. Every time somebody brings a new capability in, it extends its capacity to do new applications. And of course, with the arrival of the smartphone, we had a dramatic change in the way the internet worked, because up until that time, it was mostly dedicated circuits connecting packet switches to each other, and some radio connectivity and some satellite connectivity. But once the mobiles came along and had programming and computing capability, as well as a display, microphone, speaker, motion sensors, a touch-sensitive screen, and cameras. It's an amazing device. And to add to the ability to get to the internet was energizing. I would say that those two technologies, the smartphone technology and the internet technology, come together, and then they just become explosively valuable.
Sure.
Millions of apps have been developed, and more to come. And it's an example of what can happen when you bring the right technologies together.
Awesome. So in your Stone Soup story, it's obvious that, collaboration can give everyone a chance to learn from each other, to share their ideas, and not being afraid of, being kind of fooled or something. Talking about learning and education, designing educational programs that encourage social interactions and holistic human development is crucial for the success of students. What should we pay attention to when creating these programs?
I think the most important thing you can do is to pose problems for the students to solve, or something, maybe something to design, maybe a particular problem that you have to figure out how to accomplish. MIT has some pretty interesting examples of this. I wasn't a student there, so I don't have personal experience, but I seem to remember one of the engineering challenges was figuring out how to deliver an egg safely over, some 20-foot range and not have it break. And some of them, would figure out how to wrap the egg in plastic and everything and launch it so that when it lands, it doesn't break. Others said, well, we'll not do the air thing. We're going to do a little car that carries the egg over from one place to another. But the idea of having the students try to solve a problem that requires them to work together to gather knowledge about different possible solutions is a very important experience, not only for respecting other people's ideas, but also literally for learning how group problem solving works. Most really hard work and major advances don't come from one individual. They come from many people working or collaborating together, which is the way the internet has evolved as well.
Awesome. I do appreciate what you said about creating the environment for the students to solve the real world problems. At Thái Bình Dương University, we are trying to provide students with some kind of service learning projects where they go to the community or to the corporates and solve the real world problems over there and test their knowledge and skills learned from the academia. And that's the only way that they can be confident that they can be the owners of their future through that problem solving process.
That's a wonderful metaphor, because in Germany, for example, it's very common that you'll have students who are working at school part-time and also working in a company part-time. They take what they learned in the school and they discovered why it's useful to them when they're solving problems in a corporate environment. I had a similar experience, but it was more extended. After I finished my undergraduate work in mathematics at Stanford, I went to work for IBM for 2 years. And
Yeah.
during the course of that work at IBM, I was running a time sharing system. I was assistant engineer, had to know how the software worked. I had to learn a lot in order to do my job, but by the time 2 years had gone by, I realized I really needed to go back to school and learn about how compilers work, how operating systems are designed, and what real-time processing looks like. And so I had huge motivation to return to school and learn, because I had a practical reason for doing that. And having a practical motivation is a wonderful motivating tool. It's a learning tool. And that's why I like the idea of the students going back and forth between an academic exposure to something and actually applying it somewhere.
Awesome. Thank you very much. I feel great when we can, come to some very good ideas of how to develop the educational system here in Vietnam. I believe that we have people from the conference room who would like to ask Dr. Vint Cerf questions. So I would like to invite ideas and questions from them. Please go ahead.
Thank you for your answers. I really appreciate it. So I hope you're enjoying yourself here, though. Well, I have small questions. You talk about limitations of AI in comparison with human, right? But I think a lot of these limitations are because technologies is not developed enough now to be able to overcome. As we are in our university environment now, I'm really concerned about education and learning. What are the fundamental differences between how AI learns and how human learns? I mean, are there any intrinsic values of learning processes of human that no matter how developed the technologies is, AI can theoretically never replicate the great one of being a human that technologies can never surpass?
Well, I'm not ever going to say you could never get there, because there are too many surprises in history. For example, people thought that heavier than air aircraft could never fly. I mean, they could understand balloons and hot air balloons and helium balloons and hydrogen derivables, but they couldn't see how heavier than air aircraft could fly, even though birds fly. And so I would never argue that we'll never get there, but I will argue the following. Human beings have a remarkable ability to take a small number of examples of the real world and then to generalize from those examples. So I'm going to use, as an example of this, a table. So you know what a table is. It's a flat surface that's perpendicular to the gravitational field. So many of you are sitting at tables that have exactly that property. Most people don't think of table as horizontal surface perpendicular to the gravitational field, but they know it's a thing that holds stuff up against gravity. A 2-year-old knows this, partly by experiment. 2-year-old knows that if you have something with a flat bottom, you can stick it on a flat table and it stays there and it doesn't drop to the ground. If you have something round, it could roll off the table. So it very quickly generalizes to know what the basic properties of a table are. And then it goes beyond that. This 2-year-old would figure out, for example, that a chair could be a table because there's a flat surface that's part of the chair that you sit on. That could be a table. A box could be a table. Your lap could be a table. And so a 2-year-old can generalize from this to figure out how to use flat surfaces that are perpendicular to the gravitational field as a table. Most machines don't have the ability to model what it is that they encounter in the real world. I don't say to you that it never will, because I think if we learn how to program them to do that, eventually they might be able to do it. But I would ask you to think a little bit about how you would represent that real world knowledge. One of the things that one of the founders of artificial intelligence wanted to do, John McCarthy, who was at MIT with Marvin Minsky, and then McCarthy came to Stanford and was there just as I arrived as an undergraduate. So I had some exposure to John's thinking. He was so determined to find a way to get real world knowledge encoded in expert systems, for example. And the problem has been that we haven't found good ways of automating that process. We can create the if then else rules, for expert systems that incorporate our real world knowledge into those rules. But I think we haven't quite found ways of getting the AI systems to incorporate real world knowledge. Now, they can learn certain interesting things about the real world. So one example is recognizing objects of different kinds. You can train them to distinguish one object from another based on its shape or color or some other property that distinguishes it from the others. You can even train a robot to sort things, by taking, we had one case where we had a bunch of boxes and we gave the robot a whole bunch of objects of various kinds, a ball or a cushion or, a wrench or some other thing. And it would learn to toss these objects into the boxes to sort them. But we had to work very hard to figure out what's the reward system in the neural network that would create the correct kind of learning to discover how hard do I throw it, which thing do I throw into which box. It was all very, very carefully handcrafted. So I think we're a long ways away from being able to get this very general kind of artificial intelligence to work. That doesn't mean that we shouldn't try. A machine like that could be quite helpful. I'm hoping, of course, that we're clever about making these machines helpful tools for us as opposed to things that are out of control. And that, of course, is a decision that we get to make. How much autonomy are we going to give to these systems? And what guardrails will we put on their behavior so that if they do go out of order, they can't, the excursion isn't too severe or too serious.
Right. Thank you very much for that. Hui, do you want to follow up a little bit? You have 2 minutes.
Yes, I do.
All right. I have, because I am a fellow AI engineer as well, I am really concerned about the black box of AI. So for the black box of AI, I see that this is a wall, this is impenetrable for our engineer. So do you think that in the recent time, in a few years, can we penetrate such a paradox?
Well, I think so. The current black box phenomenon is that most of the machine learning systems that you're familiar with simply have a whole bunch of weights in the neurons, and the layers are interconnected in various ways, convolutional and otherwise. And then something comes out the bottom, right? You feed in something at the top, something comes out the bottom. And when people say, well, why did it do that? You point to this box full of neurons with various weights and say, that's why I do that. And they'll say, but I don't understand. And you say, well, we fed it a whole bunch of examples and we gave it a reward algorithm and figured out what the right weights are for the Bayesian algorithm. I do wonder, however, given what we've seen with the chatbot's facility to put words together in convincing ways, I wonder whether it's possible for us to get the system that is trained to do a particular function to also articulate what it is that it's doing. And I mean, I'm taking two things which are not necessarily commensurate. One of them is the text generating capability of a typical chatbot, and the other one is the neural network structure of an artificial machine learning system performing a task. And somehow figuring out, can I get the machine learning system to explain to my satisfaction what it is that it's doing? And you might be able to think of a reward function and a recursion mechanism, the feedback mechanism, to train it to be articulate about what it was that it did. As I said before, you're more expert than I am, most likely, in this area. And so what I just said may turn out to be, completely ridiculous. But it feels to me like we have the right pieces. It's just not clear how you hook them together. And I know many people desire very greatly to ask the machine, why did you do that? Or how did you come to that conclusion? I know I would be much more satisfied if it was making decisions about something I cared about, to hear what the rationale was to reach the conclusion.
Right. Thank you very much. Thank you very much, Robert. And thank you very much, Hui, for such exciting questions that help us understand more about the advancement and limitations of the things that are going around. So we have come to the conclusion of the talk. We would like to emphasize on some very critical issues that we have talked about today. The first thing is AI has made advancements in different areas of our lives, but it can never replace humans. Human emotions, empathy, and intuition can never be fully replaced by any technology. And that's the beauty of being a human being. We understand that in education, we should encourage real-world problem-solving skills for students. And collaboration is the key, because through collaboration, we learn from each other. We have the safe environment to contribute our ideas, and that makes the success of future students. Vint, we would like to express our deepest appreciation for your insights expressed today at the talk. We have learned very much from you as a scientist of big issues of the world that you solved ever before. And we would like to thank our audience, our professors, lecturers, staff, students, high school teachers, high school students who have engaged in this talk and be presented today. I would like also to thank our team, both editorial and the media team, who worked very hard to put this talk together. And we very much hope to see you on again next time at the new session of the series Science with Very Important Persons.